All right, welcome to the very first lecture of biology. This is going to be on scientific experimentation, and we're mainly going to be focusing on the scientific method and really going into the different aspects, or a couple aspects of the scientific method, in order for you guys to understand how we can use this to find truth. Okay, so first of all, scientific experimentation. What is scientific experimentation? What is even science? How would you define science? Now, in thinking about that, I would like to propose that science is just a way to find truth, like I said. And the way to do it is through the scientific method. So you may have heard about the scientific method, and different people propose it with 7 steps or 4 steps or 6 steps or 8 steps. Nevertheless, it's all the same thing. It's all getting at the same thing. There's some phenomenon that you're addressing. You propose a hypothesis or a question about it, and then you use some methodology to come to find the truth of the answer to that question. And you collect some data that you later analyze, and then make your some conclusion from it. You draw your conclusion from it. So that is the scientific method, as I'm sure you're familiar with. However, how did the scientific method come to be? How in the world did we even start? You may be wondering, why is this slide here a picture of what seems to be the water god, whose name escapes me, and then a volcano. Well, Poseidon was his name. A long time ago, before science, before, I guess, formal science, because science has been around since Plato and whatnot, but before formal science, everything was described as coming from the gods, or coming from a god, whatever god that is, to the civilization we're talking about. For example, in the Greek era, they would attribute everything to the gods of the Greeks, the Greek gods. In the ancient Japanese culture, they would have what are called yokai, and yokai are basically a bunch of animals, physical animals that are kind of in this spiritual realm, for literally everything. Like teacups have yokai, there's a river yokai, there's tree yokai, there's leaf yokais, there's anything has a yokai. Obviously, the animals each have yokai, and so they would attribute things to that. Ancient, Indian Americans, everything. No matter what civilization you're talking about, there was some divine explanation to the phenomena that people were experiencing at that time. Even in the Black Plague, right? The Black Plague came, and everyone thought it was a curse from God. Everyone thought that because the world was living in sin, and the Black Plague is pretty recent compared to things like ancient Greece or ancient Japan with the yokai. But even as early as the Black Plague, people were attributing it to a curse from God, and that's why we say bless you today, as some of you may know, is because they were hopefully blessing you every time you sneezed. That was a symptom of the Black Plague, so they would say bless you, I hope you don't have the Black Plague. And that stuck around, and so now we still say bless you to this day, even though the Black Plague is not a plague anymore for our day. So in this painting, you see a volcano erupting and people watching in awe. And in this culture of divine explanations, you would say, this volcanic, there's a volcanic eruption in the city. It must be that the gods are angry with us. The gods we must have kindled their anger against us, and now it's exhibited or manifested through this raging hot lava liquid thing that is coming out of the earth and destroying our crops and destroying and killing off part of our civilization and our friends and families, and ruining our cities, and so destroying our cities. And so then I can only imagine how the first scientific experimentations came around explaining the geology of volcanic eruptions. It must have been something like this, and this is what I'm going to kind of go into in the next couple slides here. So one person must have said, what if volcanoes don't happen because gods are angry with us, but rather maybe the weather around us, like, it's been a hot day today, maybe the hot day really caused the volcanic eruption. And so this person may have grabbed a friend and said, hey, how about you go to that other city over there, and then I'll stay in this city, and we'll both measure the temperatures every day, and then we'll see when a volcano erupts, and let's see the average temperatures, and then we'll kind of figure out if the hot temperature contributes to a volcano or not. And so maybe they may have collected some data, right? Or so rather, that was the method. Two guys each live near a volcano and compare measurements from the weather in those two cities. So then they may have collected this data. Let's just say it was 3 days. This is a hypothetical situation, so it's not going to be completely realistic. So we have here day 1, near volcano 1, the weather was 70 degrees Fahrenheit average throughout the day. Near volcano 2, let's say it was about 80 degrees Fahrenheit. And we're going to assume this is a time period where they have at least this measurements of degrees, whether it was Fahrenheit or not, at least some type of measurement of temperature or weather. Then the next day, it was volcano 1 had 68 degree weather, and the city near volcano 2 had 84 degree weather. And then you go on to day 3, and volcano 1 has 71 degree weather, and volcano 2 has 83 degree weather. I could be pointing these out to you guys, sorry. So, but then volcano 1 is the one that erupts, even though it has lower temperatures on average as opposed to volcano 2. That's why I highlighted volcano 1 in red, just to signify that this one is the one that erupted here. So, from this data, they must have determined, it looks like weather does not influence volcanic eruptions, right? And you may think, oh, it's a failed experiment. But if we remember, the scientific method is just a way to find truth. And if we can at least deduce, well, it's not the weather, so it must be something else that is helping us find truth. So the scientific method here was successful because we were at least able to eliminate one possible factor, the weather. And we can build upon this and say, what else might be the cause of volcanoes? And one thing building upon another, that's how science builds upon itself, and how people stand on the shoulders of giants. When they say that, they're meaning the giants are the past scientists who have found out these truths. And so, in this particular situation, we know that volcanic eruptions happen because of little holes in the Earth's crust where magma flowing under it can just escape. At least right now, we don't know what, or we can't predict this happening. We know that the factors are just built up pressure and heat, but we can't really predict those heat waves circulating in the magma, at least for now. Who knows? Maybe you guys could be the ones who come up with that innovative solution to be able to predict that in the future. So this whole example is just to show you that this is just one way that we can find, the scientific method is just one way where we can find truth. And that's why you see in some people's scientific method diagrams that it'll say something like a literature review or read past research, because there could be some things, like in this case, what if some other person said, I wonder if weather influences volcanic eruptions? Then they may be able to review this, maybe the research if this was published, and say, oh, it looks like some guy already did this or some lady already did this. The weather does not influence volcanic eruptions, and the data seem to be convincing to me, and the methodology seems to be convincing to me. I like the way they did it, so I'm going to go ahead and believe them, and I'm going to hypothesize something else. So that's how we build upon each other, and that's why if you end up participating in any scientific experimentation in the future, this will be, especially at the collegiate level, you will do extensive literature reviews of past research in whatever field you're studying, whether it be genetics, whether it be psychology, whatever. All right, so let's kind of get into it. At least for this class, we're just going to focus on the 4 main parts of the actual experimentation. So the hypothesis, the methods, data, and conclusion. Okay, I'm not really going to go into these in too much other than just hypothesis is just the question you pose. The methods are the procedures. 1, 2, 3 has to be very detailed so other people can be able to copy it if they want to replicate your experiment and be like, I'm not sure this really works. Let me try it out myself. And so you have to be able to enumerate those methods in your research, and then the data usually consists of some table or some graphs that can show what information you were able to draw from the experiment, and then the conclusion is your own interpretation of the data. So it's just what you speak, what you say, what your personal thing. Two people can interpret the same data in different ways, and that's a very, very important concept in science, because just because people cite data doesn't mean they're drawing the right conclusion. All right, so going into this a little bit, I want to get into a few vocabulary words as well as some science concepts I want you to know for this class as we enter potential experimentation, depending on whether or not you're taking this online, and how we can actually incorporate these things in order to be good scientists, or to just be able to be informed adults. Even if you don't go into science as a field, you can at least understand these things for the future when you have to make your own decisions on your own health, or your own medical decisions when you visit the hospital for your own kids, and you'll be able to say, or you'll be able to analyze anything that the doctor says, and always take things with a grain of salt, and be able to ingest what they say a little bit more reasonably and confidently. All right, so first thing, bias. Some of you may know or may not know what bias means. Here I just have a little definition. Preference toward one thing over another, usually resulting in being unfair. So usually resulting in being unfair. So for example, you see here in this cartoon where you have this lady looking over, and she says, how come she got promoted after a week when I've been here a year, right? So you see here, here's the lady, I guess, that got promoted, and here's a guy with a smile on his face talking to her. So it seems like he might be a little bit interested in her and was biased toward her when they needed someone to get a raise or to be promoted to a position that may have been vacated recently, and she'd only been there a week. But even though she'd only been there a week, he had maybe a conscious or unconscious or subconscious bias toward her and promoted her, as opposed to the lady who had been here a year and probably deserves it more. All right, so that's what this little cartoon is trying to show here in terms of bias. And then there was actually a very fascinating group of studies that have been performed on sports during the COVID years. It turns out that because of the empty seats, you guys see here the empty seats, there's no fans out here due to COVID. The empty seats seem to have promoted more referees to be more harsh, I guess you can say, for lack of a better word. That's not the right word, but at least to give more penalties to the home team when they're at their home field or home court. And this was popularized with the soccer example all over the media, but because referees were giving more yellow cards, yellow card meaning it's a type of penalty you give in soccer, you may or may not know. The referees were more likely to give a yellow card to the home team when there were no fans out in the audience. And they're doing a lot of statistical analyses comparing these COVID games with previous home games and seeing that there is quite a difference, enough to say that it's statistically significant. So that just goes to show that there was a bias in referees toward the home team when they were playing on their home field or home court, not to give them as many penalties or consequences, whatever the sport may be, because there were a bunch of fans out there. So, you could probably call that, I don't know, referee bias or fan bias or something. But nevertheless, it is a form of bias, usually in this case definitely resulting in something unfair. And so I'm sure post-COVID that they are going to be, the sports organizations are going to be looking into this and making sure that fans don't influence too much into it, because it's almost impossible to get rid of bias. We're going to get into here. But what's good to do in science and in anything you do where there is bias is to recognize it. We're humans, we have opinions, we have feelings. You can never get rid of that. But what you can do is at least say it out loud and say, hey, you know what? I have a bias toward the home. For example, the referees, I have a bias toward the home team, but I say it out loud, but I'm going to do my best to give them a penalty where I think it's right. And I hope you, the audience, can understand that as well. And then by saying it out loud, it makes it less likely. And whatever the situation may be, whether it be a boss at work, hey, that's why at work you have to actually declare, it's a legal requirement. If you have a relationship with somebody, you have to actually declare that to the Human Resources Office, because that bias can be introduced in situations like this cartoon on the left. And so, yeah, that's part of the actual legal regulation for the workplace, at least in America. All right, so here are some types of biases. One bias and two biases. That's why you say plural bias. One bias, two biases. One of the biases we're going to go over is confirmation bias. Okay, so confirmation bias is I'll just read these definitions and explain them. So mainly paying attention to information that confirms your thinking rather than objective facts. Okay, so let's break that down a little bit. So paying attention to information that confirms your thinking, okay? So, for example, internet searches. Anything you search on the internet, you can always confirm. So, for example, let's say I say, tomatoes are bad for you. And then you may say to me, no, tomatoes aren't bad for you. Tomatoes are good for you. It's a vegetable or a fruit or whatever. I don't know. I don't even know. And then I'll say, no, watch, I'll prove it to you. And I go on the internet and I find all these things on the internet that say tomatoes are bad for you, tomatoes are bad for you, kidney failure, or whatever. And then I present this mountain of evidence. Look at all this evidence that I'm showing you, all this research. That all this research shows that it's that tomatoes are bad for you. I'm actually paying attention more to the things that are confirming my thinking rather than the actual objective facts. Objective means neutral or unaffected. And so this little diagram here on the left kind of shows what confirmation bias is. There's our beliefs on the right. All of these things are our beliefs. One of them is tomatoes are bad for you. Okay. Then here's all the facts and evidence. But out of all these things, I only pay attention to these things. This is the research I found online over here. This is this. And so I'm only going to use this because this overlaps with my thinking. So I'm only going to use this one. This confirms my thinking, so therefore my thinking is true. You can easily see how this is actually a very dangerous zone to live in, because you can be living in falsehoods. You can be living in non-truths, and you don't want to be living there, because that's not ultimately where we can gain our happiness. So if we go ahead and address these things and say, okay, I could be wrong. What other facts are there? In science, you actually try to disprove your own hypothesis. In more advanced experimentation, there's a hypothesis, and then there's the null hypothesis, which you try and disprove. But we don't do that at the high school level. But you essentially, what it is you're trying to say, okay, when searching online, you say, okay, my hypothesis is tomatoes are bad for you. The null hypothesis are tomatoes is just the opposite of whatever your hypothesis is, which is tomatoes are good for you. Can I reject that null hypothesis? Tomatoes are good for you. Well, that forces me to look up, are tomatoes good for you? And then if I can find things that do say that tomatoes are good for you, then I won't be able to reject that fact. There's a difference between confirming what you say, confirming tomatoes are bad for you, and rejecting what the other thing says, tomatoes are good for you. And if you look for that, that's going to force you to look at all these other facts and evidences, and that's why there's this null hypothesis testing in experimentation in a little bit more advanced, way, which we can actually get into in the high school level if you want to work on anything to submit for state, science fairs or anything like that, local science fairs. And if you're interested in that, you can come talk to me, and then we can totally work that out. I would love to do that. All right. So, with having gone over confirmation bias at least, let's go ahead and give this video a look at here. This is Neil deGrasse Tyson. He's an astrophysicist. He has a masterclass where he teaches scientific thinking and communication, as you can see here in the title. Now, I think this is probably one of the... First of all, he's a great communicator, and I think he's basically the voice of science in today's day on the internet. And super fascinating, really funny. He has this funny show with this comedian called Star Talk, and it's really fascinating for a really fascinating person for you to look up on the internet sometime. This is his trailer for his masterclass, and I think it's a great introduction just to science in general. So I want this to kind of, I guess, serve as a little bit of an intro to this class, or at least this portion of the class, of scientific thinking. And he uses the word confirmation bias. So I wanted to present this after we went over this confirmation bias definition, because he says it in here, and I want you to have that context.
One of the great challenges in this world is knowing enough about a subject to think you're right, but not enough about the subject to know you're wrong. There's like a gazillion hours of me on the internet. In almost every case, I'm talking about the universe, black holes, the Big Bang, time travel, God. But what I'm going to do in this masterclass is teach you how to think. The goal here is to train your mind how to see the world differently, how to question what others say. I've come to realize that there are three categories of truth: personal truth, political truths, and the objective truths that shape our understanding of the universe. The interesting thing about an objective truth is that it's true no matter what. Imagine that. By the time we're done, you will be equipped with some of the methods and tools so you can turn data into information, information into knowledge, knowledge into wisdom. We all have susceptibility to bias. Search engines on the internet are the epitome of confirmation bias. And you're going to use that as evidence that you are correct? No. The good thing about science is that it's true whether or not you believe in it. What does it mean to be skeptical? What does it mean to be convinced by data? A proper skeptic questions what they're unsure of, but recognizes when valid evidence is presented to change their mind. I will equip you to not only find objective truths, but then communicate to others how to get there. It's not good enough to be right. You also have to be effective. The less connected you are to what is objectively true, the less likely you will be able to make decisions that will benefit your life, the life of your family, and even civilization itself. I'm Neil deGrasse Tyson, and this is my masterclass.
So cool. So now you guys know what to ask for your next birthday, if you're interested in that. The master classes are like $99 per class or something. Anyway, so master class, super cool. Neil deGrasse Tyson. There's really no way to kind of second whatever he says. You know, he just says it so eloquently and so engagingly. So with that, let's move on to the next type of bias. Availability bias. So availability bias is where you're mainly paying attention to information. Okay, so just same thing here, mainly paying attention to information. How? That is more available to you than other information that is less available to you. So for example, here's a little diagram here on the left. This could be all the information of something that you need to know. For example, maybe you're going out to the beach, like from this shark image over here. Maybe you're going to the beach and there's all these things you need to know about, going to the beach. But all of the information that you're using to make a decision is, I saw on the news recently that there was a shark attack. Or maybe this summer there have been 5 shark attacks already, right? because it's recent, it's frequent, it's extreme, it's vivid, it's negative, right? And this is the only information you use to go to make your decisions. So you decide, actually, I'm not going to go to the beach. When maybe, statistically speaking, you will have like a 0.0001% chance of getting bitten by the shark, maybe even at that same beach, right? Maybe that shark was just there as an anomaly or something, or maybe you're not even at the same beach, right? And so, but just because that information is more recent, more frequent, maybe you've seen a couple in your, let's say you're in California, and I'm from Florida, and there's really not shark attacks down there. There's no sharks over there. Maybe you're in California and you're seeing it more frequently this summer. You're like, actually, I'm not going to go to the beach. When statistically, the chances are you won't even see a fin, right? But you're gonna use the news, the thing that's vivid and negative, and extreme, to make your decision. This little dot as opposed to this whole thing. It's because that's the only thing that's available to you. You're seeing it on Instagram. You're seeing it on the news. You're seeing it from your friends talking about it, or coworkers at work. And because that's the main thing that's available to you, that's where you're going to make your decisions off. You can see how that's very limiting, okay? Or maybe you're going to go out and play some football, and then you're going to be, but then you see in the news as well. Usually the news is a form of the best example for availability bias. Someone got struck by lightning. As a side note, if you Google these photos, I found it was very fascinating how lightning strikes and leaves scars that are like in the shape of lightning. It's crazy. Obviously, very devastating to a lot of people, as it can take away their lives. But I thought that was an interesting physical phenomenon. But anyway, so you may say, I'm not going to go outside because, or when it's raining, or maybe it's raining, there's a thunderstorm outside, and now before, when you used to just walk normally, maybe in a thunderstorm from your car to inside your house or jog, you may like hesitate, wait, let me wait for a lightning to strike, and then I'll go right after because I don't want a lightning to strike because I saw it on the news, right? You're basing your decision making on the information that was recently and most vividly made available to you. So, availability bias is basically mainly paying attention that is more available to you as opposed to the less available stuff, right? In-group bias, okay? In-group bias is when you're most likely thinking in a way that your social group thinks, simply because they are your social group. Not because they're right, not because of any objective facts, but because those are your groups. So, for example, maybe you're hanging out with some friends and they think this one shirt is cool, right? Oh, or I got this from H&M. H&M has such great apparel or clothing, whatever. Then you may say, oh, my friends think H&M is good, therefore now I think H&M is good. Or I personally love Cotopaxi. I have some friends that raved about Cotopaxi. And then now I can say, oh, I love Cotopaxi because I love their mission, I love what they do with the colors and saving material, and that's my type of value, that's my in-group. So now I like Cotopaxi. This could be the same with politics. Usually you grow up in the political thinking of your family because they're your parent, because your parents are the ones who inculcate you with values and philosophies, and that's what you learn from, and so that they're your social group. And when they say we're Republican or we're Democrat, that's what you're going to say, or we're independent, we're constitutionalist, whatever. Then that's what you're most likely going to think, and that's the way that you're going to most likely think because they're your social group, they're your in-group. Same thing with religion. You may be a believer in God, you may not be a believer in God. Regardless, whatever your parents inculcate you with, that's your social group. That's probably what you're going to be, the way you're probably going to think. So, and it's instead of objective facts. Now, here, don't interpret this incorrectly for a second, if I may. Obviously, there are things that I want my kids to learn that are, hopefully, using the influence of in-group bias by me naturally being their dad or their one of their parents, such as moral values, and yes, we are a God-fearing family, and political persuasions and everything, and so I want them to feel this way. However, I don't want them to believe the way I believe or have my same morals just because they're part of my family. I want my kids to think for themselves and say, and decide for themselves, yes, that is a good moral to have, because yes, it does make sense, using the objective facts. Yes, I do believe in God because my objective fact is my personal experiences. Or yes, I do believe in this political way because the objective facts persuade me this way. And I don't want my kids to be dependent on me. I want them to be independent as they personally interpret their own objective facts in their search for truth. And so I don't mean to present this in-group bias in a negative way, because bias is usually unfair, usually results in being unfair, but not always. Bias is used loosely in its implications for good and bad. So here you have an interesting cartoon. In this left civilization, you're thinking, our blessed homeland, and the right civilization, they're saying, their barbarous wastes, right? But it's our blessed homeland. And then there's like mirroring comments here. Our glorious leader, their wicked despot. Our great religion, their primitive superstition. Our noble populace, their backward savages. Our heroic adventures, their brutish invaders. So it's interesting. The way that they look at it is based off their in-group. This is their in-group, and the right is obviously has a different in-group bias toward these people. All right, and so this is just another abstract visualization of that in-group bias idea. All right. Last type of bias here, we have publishing bias. So basically, this is thinking that research supports your argument because of the positive results of the research. Like, for example, an all-fruit diet, if you're looking down here, there's an all-fruit diet, and say, oh, the research supports my argument because of the positive results of this research. But in reality, the research that disproves your argument just never got published, because the journal publishers, like for this guy, this is a journal publisher, they don't like to publish research with quote-unquote no results. So this is an interesting one. Fruitarian diet and blood glucose control. So a case report. So one person implemented the fruitarian diet and was able to control their blood glucose levels after being diagnosed with type 1 diabetes. If you click on this link, by the way, I'll have some of these every once in a while in the notes in your PDF version. You can just click. That means you can just click on the photo for what if you're interested in going into that link. and you can read the abstract here and later see that there were other health complications by only going on the fruit diet that they do admit in here, but I thought it was just a good example of showing publishing bias. So you may find a bunch of research that supports your idea, but that's just because the actual research a ton of other research that disproves your argument never got published because the journal publishers, they're like, it's too boring, So, all right, that's publishing bias. So, in summary, we have these biases. There's confirmation bias, where you only look at the information that confirms what you're thinking. Availability bias, where you only think based on the information that's available to you. In-group bias, where you basically say, this is the way we think, so I don't think the way you think because you're not part of us. And then publishing bias, which is basically a bunch of research doesn't get published, only the quote-unquote interesting ones. So you may be deceived just because there's no research published doesn't mean that there isn't research on that. And there's so many more types of biases. You're gonna see the word bias now probably come up a lot now after going over it now a lot in this video, and you're gonna see a bunch of ways people using the term loosely. There's like gender bias, or we went over a little bit about sports biases. There's judicial bias, and cognitive bias is just a general term for like all these biases. And so bias is just a way a word to represent that our judgment is not completely surrounded on the objective truth. But the way that we address that in science when we're trying to find the objective truth is to state that out front and say, I have a bias toward this. For example, if I am a researcher and I'm trying to figure out whether or not religious people get better grades or on in school as opposed to non-religious people, then and I personally myself am religious, I should state that because that's an interesting bias that would be very enlightening for the reader to present. If I'm a reader and I'm saying, yeah, I wonder, do people's religious actions correlate with better grades as opposed to non-religious action, not having those religious actions and rituals, then I might want to know, well, if the scientist is religious, then I'm automatically going to think what? Well, they're probably going to say that yes, religion, they're probably going to lean toward this one. But if you don't say that if the scientist doesn't say, if I don't say, by the way, I'm religious and I'm doing this study, then I may think like, well, maybe this person doesn't have any biases, but they actually do. And so it's better to say, I am religious, I am biased, therefore I am biased toward this group here. However, I'm putting that out front, so I'm going to make my methods in a rigorous way where I can make sure that each group gets its equal attention in rigor. Okay, so the way we address biases in science is to actually say it out loud. All right, so that was all about methods. So biases in our methods. And by the way, I should give a couple examples. So for example, another example, there was there were a couple students who did some stuff, research projects last year. Like for example, on watching TV before you go to bed, right? Is watching TV before you go to bed good or bad for you, right? Well, if the person likes watching TV before they go to bed, they're probably going to say, it's good for you, right? Or it has no effect on your sleep. And when in reality, it has a very bad effect, or they may not know how to kind of measure that. And so by saying in the beginning of the research, hey, I'm actually biased, I actually watch TV every single day for 30 minutes or whatever before I go to bed, then you're presenting that bias out front, and the reader can say, oh, okay, they're doing this research on does TV affect my sleep, but and they do this every day, so they're probably going to say it has no effect. Which means if they go around and say actually it does have a negative effect, then you're going to say interesting. They must have done some pretty rigorous methods in order to disprove themselves, right? And so that's one of the reasons why you present biases in your research is for the reader to be convinced of your results and to dig into your reasoning a little bit more thoroughly. All right, so all of that is about methods. So your biases should inform your methods when you perform your own experiments throughout the year. All right, data. So data is plural, by the way. This is plural. Datum is singular, this piece of datum. But people say piece of data so often, it's almost correct now. So out of these four, so we focus on this one. We're not really going to focus on this or this too much. But methods and data. So now we're getting into data. So we just did methods. So data, what is data? Data is just basically information. Information you collect from your experiment. And there's two types of data. One is quantitative data. The other is qualitative data, or sometimes just reduced to quant and qual. You can kind of see by these photos, you may be able to deduce what the difference is here, especially by just looking at the word quantitative. You can see quantity and quality. So let's dig into these. Quantitative data is basically information usually containing falsifiable numerical measurements, right? So for example, I just put this little image here from the Earth and Space Science exam, or semester 1 exam, because it uses the word falsifiable, and it was an easy chart to go to for the word falsifiable. But it's going to be numbers as well. Quantitative data is just, you can equate that to numbers, right? So what does falsifiable mean? Falsifiable means you can prove it false. So Pluto's surface is made mostly of frozen nitrogen. Well, all you have to do to prove that true or false is just measure the nitrogen, through the satellites and whatever radiation measurements we have up there, and say, is the amount of nitrogen gas greater than 50%? Yes or no? Well, I can prove that to be false with the measurements that we take from that NASA and other interplanetary organizations take, and you can very easily measure the amount of nitrogen with those satellites and say yes, it is greater than 50%, or no, it's not. I'm proving it false. It's falsifiable because you can actually measure it and use these numbers to prove it false. Another example: Pluto's orbit is slowing down due to tidal friction. You can also measure that velocity of Pluto's orbit by just taking the measurements of it and seeing what the tidal friction how it affects it. So anything you can prove false is falsifiable. Is usually some type of objective data, and for quantitative data, that objective falsifiable data is going to also be numerical. So you may be in a laboratory taking some experiment and trying to figure out what's the percent of protein in this particular substance, or what's the exact chemical X in this substance. Maybe from a forensic scientist, they're trying to figure out what type of metal is this, to figure out what type of bullet was traveled through here or something like that. So it's some type of and that's measured through some type of quantitative analysis here. It's falsifiable, and you can include numbers in there. All right, so that's quantitative data. Qualitative data is all non-numerical information, so usually in form of surveys, observations, etc. And a lot of people may think of this as a lower form of research or science. However, and it is not as exact. However, it is very informative, and we would not be where we are in civilization without this type of science. In fact, there's here are a couple examples. This is Jane Goodall. Some of you may know her name. She's one of the very first, I guess it would be a chimpanzee ethnographer, but basically, she lived with chimpanzees for so long. She was like one of the first people to do these like in-depth observations, and she came up with a whole science of analyzing chimp behavior and sociology and their culture. And this is a beautiful photo of her with a little baby chimp here, and there's tons of hours of her online interviews, books, research papers, and now she has a thing on Disney Plus, I think under their national, or not national, but the documentary kind of side of it, and she didn't have too much quantitative data. That's not really the type of research that you would have a lot of numbers. However, she would have a ton of qualitative data, a bunch of observations, a bunch of her own etc., maybe including her own research journals, her own analyses of all these different things that the chimps do, and maybe even this etc. may also include audio recordings of the data of the chimpanzees, the way they communicate with each other and try to, or even video recordings could also be the etc. here. In this case, in this middle photo, there's this sociologist who actually was not undercover with a gang, but he did his PhD on gang behavior and with their culture and different the way that they think, the way that they behave. And he did this for 7 years. But there was a gang leader whom he calls JT, I think, or something. And JT, so as to not expose his identity, but JT knew that he was a sociologist. And so he just literally walked up to different gangs in I think in Manhattan or Harlem or something. And he just said, "Hey, I'm a sociologist. I would love to examine you guys and your thinking and behavior, and I won't tell the police about any of your doings. This is purely for a scientific experimentation and exploration." And there happened to be a gang who actually allowed him to do that, and he was participating in things that would in the gang world would have given this guy about $100,000 a year if he were participating actually, and but he was just kind of a shadow for the gang leader. And then one day he happened to mention, well, it doesn't seem that difficult, to participate, and da 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 da, or to be a gang leader, because this guy JT was making it, seem kind of easy. At the same time, I'm not really sure the complete details of the conversation, but he's like, you think it's easy? Then you be a gang, like, you take my spot for a day. And there's an actual, and so he accepted, and so after a lot of, thinking about it, but he talks about his experience. He wrote it in this book. Obviously, he has published research, and he's a sociology professor now at Columbia University. This guy Sudhir Venkatesh, and I linked the audio of his of an NPR interview that they did with him on this photo. So if you click on it, you can it'll take you to, in your PDF. It'll take you to that recording. Last but not least, there's this example here of marriage research. There's tons of research in psychology and in marriage, particularly for therapists, to help inform therapists on how they can provide best marriage counseling to couples. And so all that has to come from somewhere, right? It comes from research. There's actual couples who, when they go to therapy, they agree to participate in research, and because of that, we're now building on the shoulders of giants, and have this plethora of knowledge on how to best help marriage counselor or marriage therapists. Same thing with sleep therapists. There's a bunch of stuff on sleep and observations there. I had a professor at BYU who was actually a marriage counselor, and he said a psychiatrist or a therapist or whatever, I'm not sure if he actually diagnosed drugs, so that's the difference between psychiatrists and psychologists. But anyway, so he helped marriage couples, and he said during one of their research studies, when he was getting his PhD, he said that they would put couples in a room, and they put a video camera in there, and they would record how long they would record their arguments. And they said, basically just put them in a room and say, okay, talk about what you normally talk about that gets into an argument, and we'll come back once we have enough recording. And so they walk out, and he said, to my surprise, you thought that they might be hesitant because we're observing them, but man, they just get into that really quickly. And so they ended up just, after 5 minutes, usually per couple, they would just come back in the room. Actually, that's enough. We got enough for what we need for the study. So thank you very much. And so there's tons of this is just a third example. There's tons of types of qualitative research. Hopefully this expanded your mind a little bit in terms of these different types of research, and basically what types of research you can do, what types of scientific studies that you can do to find truth in whatever you might be interested in. I'm sure whatever ideas of science that you come up with, there have been other people in the past who have worked on it already, or at least something similar, and that means that you should only read their stuff before you dig into your science research, because then you will be standing in the shoulders of giants, and you guys are the ones who are going to be the future adults, future leaders of this country and of this world. And in order to create a successful civilization, we have to stand on the shoulders of these giants of who have done past research in all these different types of fields, whether it be science, or whether it be engineering or politics. And you guys are the ones that have to be using the scientific method, using your analytical skills, and trying to get recognized, not get rid of biases, but recognize your biases and say, how can I contribute to some good in this world? How can I stand on the shoulders of giants? How can I teach my kids the best way? How can I contribute to my job in the best way possible? How can I contribute to my country in the best way possible, according to the truths that I am analyzing, and hopefully in the most objective way possible, building this country and building your own life upon. And so that's scientific method, and we'll see you in the next class.